Hey, Brian.
Hello,
You ready to go there?
I'm ready.
Did you get the intro? Did that come through?
I heard something a couple minutes ago.
Okay,
Not not just now though.
okay. Let me start from scratch though. I may have had an audio issue. Hello and welcome to everybody to the DB2 LUW Fitness Plan webinar. My name is Ray Cameron. I'm a part of the XTIVIA team moderating today's webinar from Colorado Springs, Colorado. Today's presentation is from XTIVIA, and we have solutions and services covering business intelligence, data warehousing, portal and application development, and of course, data management. All of our attendees today are on mute. We will, however, be taking questions throughout the call, and we'll answer as many of those questions as we can before the webinar. We will leave some time at the end to do so. In case you are new to GoToWebinar, you'll find the question and answer tool on the right side of the screen in the GoToWebinar panel. And our presenter today is Brian Fairchild. He's the DB2 Practice Lead with XTIVIA. Brian has over 12 years of success and expertise deploying enterprise database solutions and implementing scalable systems, as well as automating and improving critical processes. He supports many clients in the healthcare, manufacturing, banking, transportation, and retail fields. And most recently, I think, proudly won the third place prize in the annual DB2's Got Talent contest hosted by DBI Software. So with that, Brian, what do you say we jump into the DB2 LUW Fitness Plan?
Well, let's do that. Thank you, Ray. So today we're going to talk about getting a DB2 database into shape, primarily identifying our primary storage and CPU consumers. We're going to talk about how to trim unnecessary consumption by conserving and reclaiming storage. I'm going to give an example of value compression, and I'm going to talk about some storage management features that are new in DB2 10. Most of my presentation is based on DB2 version 9.7. We will touch on DB2 10. And then we're going to talk about maintaining DB2 fitness. Along the way, I have some pictures from movie characters and scenes, and I thought it'd be fun if everyone that attended kind of kept track. At the end, we'll see how you did if you can remember some of these movies. Does this sound familiar? DB2 file systems and drives are filling quickly. Queries and reports that used to run quickly now take too much time and too much CPU. The DB2 instance is bursting at the seams. Okay, the first section is to identify our consumers of storage and CPU. We're going to touch on transaction logs, archived logs, table spaces, tables, indexes, backups, and poor performing SQL. Active transaction log basics. All primary logs are allocated when a database is activated. Secondary logs are only allocated as needed. Default log sizes are very small, so they've likely been increased, but have they been increased too much? Too many primary logs grab onto too much unused storage. If each log is too large, it might take hours to fill and the others go to waste. Don't let your log storage be wasted. For archived transaction log basics, setting up archive transaction logging allows for online backup and point-in-time restores. Archive transaction logs hang around like a bad house guest. Put a plan in place to manage these logs to conserve storage, and we're going to discuss that plan. On a busy system, archived logs can take up gigabytes of storage. Which ones should be kept and which ones can be removed? It's important to manage these logs or they will manage to ruin your day. Tablespace storage basics. Tablespaces have containers on your storage system. The data is stored in pages in the container. SMS tablespaces are managed by the system, and DMS tablespaces are managed by the database. DMS perform better but take more effort to manage. DMS tablespaces can be made to auto-resize. The auto-resize tablespaces love to take storage from your system, but they don't like to give it back. Here's some questions you should ask. How much storage is my tablespace holding? How do I reduce the number of pages in my tablespace? And how do I reclaim that freed up storage? Table row fragmentation. As data in a table is updated or inserted, it may not fit on the same page. These are called overflow rows. DB2 uses more CPU to access data in overflow rows as it scans multiple pages. Overflow rows can also use more storage in a table space than necessary. So why should we care about bloated tables? Well, CPU is wasted when DB2 finds fragmented rows. Memory is wasted as the buffer pools hold fragmented rows, and table space storage is wasted because tables are full of white space. Index fragmentation. As data in tables is updated, the corresponding indexes on the table are also updated. Many table updates can lead to fragmentation of index pages due to page splits. Fragmented indexes take more time and resources to scan. Your indexes should be lean and mean. I/O costs increase because more index leaf pages must be read to fetch table pages. Buffer pool memory and I/O is wasted on page splits. Indexes can contain record identifiers that are marked for deletion but not removed. DB2 backups. Backups are necessary, but many clients don't know how to manage them. DB2 has many ways to manage a backup and recovery solution. Backups that take too long or are too large waste CPU and storage resources. So why should we worry about our DB2 backups? Well, the database backups can account for a huge portion of your storage use. Backups that take too long are limiting resources for the rest of the system. So poorly performing SQL is the #1 consumer of CPU. A poorly performing query can hold locks too long, and a domino effect of locks and CPU can overload the system as a result of one bad query that runs often. So why should we find these outlaw SQL queries? Well, the combination of poor SQL and poor indexing is the #1 thing I find in struggling systems. If you find and fix the bad SQL performers, you will likely delay or eliminate the need for hardware upgrades. So this next section is about trimming this unnecessary consumption of storage and CPU. So let's first start with transaction logs. Some parameters for transaction logs are log file size, log primary, and log seconds. Log file size is the size of each log. If your logs are being filled every few seconds, you should increase this size. If logs are only filled hourly or more, you can consider reducing this size. Log primary is the number of primary logs. If you're able to reduce this number, you can reduce the amount of storage held. Log second is the number of secondary logs. This number plus log primary can add up to 255. Using secondary logs during peak periods is ideal. So how do we size these transaction logs? You need to understand your workload and be able to handle the spikes in order to avoid a transaction log full errors, but you still want to eliminate wasted log space. Here's a query to evaluate log usage from the SnapDB sysatom view. It takes a look at the total log available, log use top, and secondary log use top. If total log use top is nowhere near the total log available, you can reduce the size of your logs or the number of your primary logs. If the secondary log use top is low, you should consider reducing the log file size or log primary because you're probably holding on to space that you never use. It's perfectly normal to use many secondary logs in peak periods. They're only allocated as needed and go away when you don't. So let's discuss managing archived logs. Some parameters are log retain and log arch meth1. Log retain is on. The logs get closed and retained as archived logs. These logs are necessary for recovery in the event of a crash or a point-in-time restore. Archived logs are also necessary for an HADR pair to stay in sync. Log arch meth1 turns on log archiving and can tell DB2 to archive logs to a new location. This is useful for archiving logs to TSM or simply to a separate directory. Here's an example of how to turn on log arch meth1 to disk. It does require a full offline backup after you turn this on, so don't do it during business hours. So let's discuss managing these archived logs. A good way to do it is to use the prune and delete command to prune the history file and delete recovery objects associated with it. This will delete backups associated with the history file. An example of the command is the prune history 2012-0630 and delete. We'll delete all entries in the history file, the backups, and also the archive logs prior to June 30th, 2012. If the autodel object is set to on in the database config file, you only need to do the prune command and it'll automatically delete the associated objects. What I prefer to do is use the logarchmeth1 config parameter to archive logs to a separate file system. This makes it easier to manage them in my belief. Removing logs from this file system on a scheduled basis is simple to do with an example of this Unix script that finds logs in that file system, deletes ones that are older than 5 days. And here's an example of how you would do that on Windows. I believe it's easier to have these separated between active logs and archive logs. A bad way to do this might be to set log retain on. The archive logs and active logs are all in the same directory, and then you build a script to delete just the archive ones. This can be a little dangerous because occasionally a transaction or a connection to the database is held for a couple of weeks that may be holding a log open. Your script may see that log is older than 7 days and delete it even though it's still active. In that case, you're probably doing a database restore to get your database back. Ugly way to do this would be to set log retain on. Archive logs and active logs reside in the same directory, and then you wait for system administrator to start deleting logs when the file system fills, because it will fill. So let's talk about tablespace storage eaters. Here's a query to check your tablespace utilization from the Tablespace utilization sysadmin view. And I want to show an example here. The bottom line would stand out because the tablespace utilization column on the far right, the very bottom line is it's only 0.11% utilized. We can see we have 200,000 free pages in the tablespace. So let's talk about how to free up pages above the high watermark. The high watermark determines how much storage you can take back from a DMS tablespace. When a table or index is dropped or data is purged, space is freed up in the tablespace. However, until any kind of storage consolidation operation is performed, the high watermark remains at the previous level. If the used pages is lower or equal to the high watermark, then you can easily reduce the size of the tablespace by the number of free pages. So back in our previous page, that example of tablespace 17, we have 200,256 total pages. We see the high watermark's only 224. So I can delete or reduce the tablespace by the total amount of free pages using this alter tablespace command. And after I run that, I take another look at the DB2 PD output. I can see that the total pages is now down to 256, and we freed up 200,000 4K pages, or about 800 megabytes. So in version 9.7 is a new feature called reclaimable storage. Before version 9.7, the only way to release storage was to drop containers or reduce the size of containers above the high watermark. The high watermark had to be reduced, and it was pretty painful using the DB2 Dart utility. With tablespaces created in 9.7, we can easily reduce the high watermark and reduce the size of the containers. So we can lower the high watermark and reclaim storage. A good way to get started is this query that I have for you using the monget tablespace function. And what it'll tell you is the reclaimable space enabled column here. It tells you which tablespaces have that enabled. It'll also tell you how much, on the far right column, how much free space is below the high watermark. So in this example, we can reduce the user space 1 by 128 pages very easily with this reduce command. So now let's look into table storage. It's important to find the tables that have fragmentation, and looking for overflow accesses is a good way to indicate that a table has a lot of fragmentation. And here's a query for you of the SnapTab sysadmin view that lets you see the overflow accesses by table name. And in this example, our test table has 2,200 overflow accesses. It's one thing to have overflow rows, but if those rows are never read, it's not killing you. But if those rows are constantly being accessed, then we have a problem. We need to get a table reorg in place. Another way to see if your tables need reorg is reorg check, and most DBAs know all about the reorg check utility. Here, this second line, I have the the sysproc reorg check TB stat system procedure, which you can run against an individual table or all tables for that matter. Now, the reorg check output is sometimes hard to read, but here, if the field 1 is marked with an asterisk, we know we can reduce I/O costs with a reorg. Field 2, we can reduce storage costs, and field 3, we could also reduce storage cost if we do a reorg. Let's look a little closer at the offline table reorg. Advantages are it's the fastest method. The data comes out perfectly clustered. Indexes are rebuilt automatically, and we can use Tablespace to build a copy of the table. Disadvantages are there's no access to the tables. Well, read-only during part of the process. There's space required to rebuild a table, and there's not much control once it's started. Let's talk about in-place or online reorg. The advantages are there's full table access, except during the truncation phase. We can stop, start, pause, and resume it. We reduce our storage requirement, and it's also recoverable. Disadvantages would be imperfect data clustering. Indexes are not rebuilt, so they'll likely need to be reorganized afterwards. So during an in-place reorg, it's fully logged. It's recoverable if your system fails or the transaction log fills up. It's only allowed on non-partitioned tables. The truncate phase at the end is optional. This phase deletes unused space in the table. So if you're trying to reduce space, I definitely recommend using the truncate option in your reorg command. This is really the best method for 24/7 database. I'll share an example with you I had with a client of ours. They had a table that was 11 gigabytes in size. It was in a 4K page size table space. The row length was 3,500 bytes, so it's pretty close to the limit for 4K page size table space. In-place reorg was started, but it was going to take over 36 hours, so we stopped it. We found the solution would be to move the table to an 8K page size table space. The reorg in place now takes less than 10 minutes. It was a huge change, mainly because there's more space in each row. Each row can be reorged within the same row. So consider ongoing table maintenance when you're choosing a page size. Here's some commands for your toolbox to hang on to. This first one is the reorg check TB stats procedure that we can flip into a reorg table script. The second one is a way to check your overflow accesses. Is a good way to know when your tables need reorged. And the third one is a good query on how to monitor a reorg. I'm going to touch on range partition tables. Range partition tables can be organized and partitioned across multiple storage objects because according to key columns in the table. It makes it easy to roll in and roll out table data by partition. Data partitions can be added to or attached to and detached from a partition table. This makes it simple to purge a range of obsolete data. So this may be an option if you're trying to purge old data. It's simple to detach a partition into a separate table. If later you decide you don't need that data, you can drop that table. You freed up a lot of storage. Let's touch on index maintenance. So a good way to look for indexes that need reorg is this sysproc reorg check IX stats procedure. Just go over the output real quick. If F4, F5, or F6 are marked, we need to do a full reorg of the indexes that can be done online with write access. If F7 is marked for reorg, we can just do a cleanup only all. F8, we can just do a cleanup only pages. These cleanup only options are quicker. They don't completely rebuild the indexes, so if only F7 or F8 is marked, that's all we need to do. Some additional health indicators for our indexes are in the systat.indexes catalog view. I do recommend after indexes are reorged to get some baseline data out of these columns. If you keep an eye on these, then you know you have a good indicator of when the next reorg should happen. Let's touch on what happens during an online index reorg. First phase is the build phase. All indexes on the table are rebuilt as a shadow copy. Log catch-up phase, any log transactions that took place during the first phase are then applied. The object switch phase is the phase where it switches out the new old indexes with the new indexes. There is a table lock during this phase, so keep that in mind when you choose what time you're going to do this. And then the cleanup phase, the old index objects are removed. The number one way to reduce index storage is to drop unused indexes. And there's a new feature in 9.7, a table function called monGetIndex. And I have a query for you here that'll let you know how many times an index has been scanned. If an index has been scanned 0 times since your last database activation, it's safe to drop. So I'm going to touch on table and index compression. There's compression capabilities included with most editions of DB2 9.7, and one of them is called value compression. If a table is created with the attribute value compression, the system consumes 2 fewer bytes for each table entry in columns, basically variable length columns. So it depends on your table. This doesn't work for all tables, but if you have varchar columns, lob columns in a table, it may be a good candidate for value compression. Again, a thing about value compression is it's free. It's included with the edition of DB2 you probably already have. The other type is deep compression, and that comes with a DB2 storage optimization license. So it does cost. You get a lot more compression. Includes compression for XML storage and tables and indexes, and there is a significant storage savings. Most of my clients are not using the storage optimization feature, so a good candidate is the value compression. I'm going to give you a quick example of how to check your tables on this. So I had a client that wanted to reduce some storage space in tables. We listed out the 20 largest tables in the database with this query. I then ran each table through a value compression check query. And in case you're wondering, this presentation will be available for replay so you guys can get all these queries out of here. But this value compression check query is very useful because it can tell you which tables may be good candidates, because not every table is. We had one table that returned a positive value of 14. The table is about 4.7 gigabytes in size. So as a test, I first did a reorg and run stats on the table so I could get a very accurate size of before compression. Turned out to be about 4.7 gigabytes. I then turned on value compression with this alter table command. The reorg then did a full reorg on the table, run stats on the table, checked the size afterwards, and it was about 4.2 gigabytes. So we saved about 10% on the size of that table. You can see here I did the table space sizes before and after. We freed up about 103,000 pages in the table space. Again, it's simple to do, and it comes with your edition of DB2 you already have. Just a lot of people don't know about it. So new in version 10, we have adaptive compression, and this goes along with the storage optimization feature license. But table data can be compressed with page-level compression dictionaries in addition to the row level. They're automatically maintained when data is inserted, hence the name adaptive, and there's no need for table reorgs to compress new data. Another really cool feature is multi-temperature data management. It's based on storage groups, which are mapped to different types of storage. You can assign automatic storage table spaces to these storage groups, and you can dynamically reassign a table space to different storage groups with the alter table space command. With this, you can put frequently accessed data or hot data on expensive fast storage, such as solid-state drives, and infrequently accessed data on slower, less expensive storage. You can dynamically move data from hot storage to cold storage, and it's a good recommendation for data warehouse systems or mixed workload systems. And also new in version 10 is a way to reclaim unused space in indexes. When there's basically a new option to the reorg indexes command called reclaim extents. This runs very quick, doesn't completely rebuild the indexes, but frees up space. So let's talk about backups. Backup basics: always compress the backups using the DB2 compress option in the backup command. You should keep at least 2 days of backups on disk for your production systems and save older backups elsewhere, usually to TSM or tape or whatever you have at your shop. Smaller systems can consider using the automatic backups for easy management. Automatic backups automatically prunes old backups and takes new ones as needed. I recommend monitoring backups to make sure they've completed and making sure you manage the disk space they use. For large systems, a combination of full, incremental, and delta backups can save storage. So let's talk about that mixed backup strategy. Incremental backups back up all data that's changed since the last full backup. Delta backups back up all data that's changed since the last backup of any type. So an example of a strategy, weekly strategy of that would be Sunday taking a full online backup. Monday and Tuesday are incremental deltas. Wednesday would be another incremental. Thursday, Friday, incremental deltas. Saturday, incremental. So you're backing up a lot less data. They run a lot faster. They hold a lot less storage. There are some restore considerations in these cases. The restore command is a little different. You're going to have to use the incremental automatic options. If you're restoring an incremental backup, you need the latest full backup. It's going to have to read from that, so don't remove the latest full backup. And besides needing the latest full backup, you need all the subsequent incremental and delta backups. So don't use the prune and delete commands more than or later than the last successful full backup. If the history file entries for backup type and location are gone, you'll be unable to restore the database. Here I have a command for monitoring backups on the sysadmin view called DB history, and this is pretty simple. We can see that our last backup was a full backup, see the location of it, see the start time and end time, and the SQL code is null, so that means it was successful. The one previous to that, we had a SQL code of 2413. It failed. In this case, it failed because online backups weren't enabled. So let's touch on finding SQL slackers. Could really do a full presentation on this. I'm going to touch on it briefly on some of the methods I use for clients. First thing I like to do is rank the SQL that's running on the system, and I'm going to show you some commands that you can use to pull out data from the Snap Dynamic SQL sysadmin view. We can sort these by the top 10 SQL statements by total execution time, average execution time, average CPU time, number of executions, and number of sorts. And with this output, you'll have a good idea of what's running on your system, what's taking CPU, what's running most often, what's doing most sorting, and from this you can get a good idea of what you need to run through the DB2 advisor. It's always a good place to start. Most often, if CPU is being consumed, there's indexes that need to be created. Now, this is a problem I solve for a client. The dynamic SQL snapshots or the Snap Dynamic SQL sysadmin view doesn't show the application name or the authorization ID that's running it, and they need to know that information. So here's a query I have that pulls out data from the application Snap Apple Info, and Snap Statement sysadmin view. And it shows the authorization ID, application name, rows selected, rows read, percent selectivity of executing agents. Percentage of selectivity is a good indicator of indexes being needed. If you have a ton of rows being read but very few of those being selected, you're consuming a lot of CPU and you need an index on that query. So what works in their case is we run this every 30 minutes. It inserts the output into a history table, and then we can go back every week. We can see what was running, who was running it, when, and how much CPU it was using. So let's touch on maintaining a lean DB2 database. What I recommend is a weekly reorg of tables and indexes. At the very least, do a monthly reorg of tables and a weekly reorg of indexes using the cleanup option or reclaim extents option. Always execute run stats after a reorg. Keep only the number of backups and days of archive logs on the system that you could possibly need to restore back to. Older backups and logs should be saved to other storage and removed from the server. Doesn't do you a lot of good in my eyes to keep 7 to 10 days of backups on your production system when there's no possible way you'd ever restore further back than 2 days. Always compress backups. Always monitor table spaces for page utilization, and beware of auto-resize table spaces that are gobbling up too much storage. And always monitor SQL using the snapshot monitoring or scripts to flag queries that need indexes. Okay, we're to the summary section. Let's wrap up here. We're going to go over what we talked about. We're always reduce the amount of primary transaction logs or the size of each log when possible. We talked about putting a management plan in place for the archived logs and delete logs older than needed from your storage with a script or scheduled task. Identify table spaces that hold too much storage and reclaim it. Compress all backups and consider a backup strategy that utilizes incremental or delta backups. Identify tables with overflow rows being accessed and reorg them. Find indexes in need of reorg and execute it. Consider range partitioning so that partitions can be detached if not needed. Identify table spaces that hold too much storage and reclaim it. Identify tables that could benefit from value compression and implement it. Cut CPU by tracking down and creating indexes for poorly performing SQL statements. And drop indexes that are never scanned. This is the simplest method of reducing storage and CPU usage. That wraps up my presentation.
Brian, great
job.
Thank you very much. Yeah, great job, Brian. Thank you. That's a lot of information in 30 minutes. And we do have one question that's come up, and we'll get to that in a minute. Anybody else that has some questions, I'm sure there's got to be some out there, and we'd be glad to. We've got plenty of time to address those, and if we get through what we have before the top of the hour, we'll go ahead and wrap up. But I want to make sure we do get a chance to address any of the other questions that folks may have that they haven't posted yet. I was thinking, Brian, a couple folks came in later after the introduction, and we're probably wondering what in the world are all these images on the pages. And maybe while we're letting people get their questions formed and written down, I'm just curious if anybody, maybe somebody could throw up a couple movies that they saw come up on the screen, at least see if they were really paying attention. So, and I think you can post that in the questions too. So you can post your questions. If you saw a movie that you recognized, it'll give us a little sense of what generation you're from as well, I think. But Brian, let's take a look at this first question, which is if you have any recommendations for customers running 9.5.
Well, this presentation basically is identical to what would be the case in 9.5. The only difference is 9.7 has those reclaimable storage option. So all of this pertains to 9.5 systems, with the exception of lowering the high water mark in your table spaces. I'm afraid that's kind of a painful process of running the DB2 Dart utility against a table space, and it usually recommends unloading all the data in the table space and reloading all the data in the table space. And it's definitely can be done. It's possible. It's not as easy as it is in 9.7, but the rest of the presentation also pertains to 9.5. Okay.
And I'm just wondering, the question came from a visitor we have from Greenville, South Carolina, and if you have any additional specific questions about that, I'm sure Brian would love to address those. We do, just to give people a sense of where we've got visitors from, we've got a number of people from the Chicago area, Fort Lauderdale, Costa Mesa, California, Atlanta, Austin, Plymouth, Minnesota. We've got a nice representation from across the country. Any other questions from our attendees? And maybe, Brian, if maybe you know of some questions, and we didn't really prep this beforehand, but there are any questions that you get or that you assume people might have after unloading so much information on them? I would. You probably.
Yeah, a lot of the.
Go ahead.
Yeah, some of it would be around the compression. A lot of people ask about compression. They wonder, deep compression, does it require a separate license? And the answer is yes. That's why I showed an example of the value compression, because it is included with the additions of DB2 that most of our clients already have. But yeah, most of the questions I would say are around compression. And also, a lot of people haven't heard a lot about version 10 yet, and I'm really excited about those new features, including the multi-temperature data management, being able to move your hot data to fast storage and your cold data to less expensive storage. So those are other things that are really cool coming out in version 10.
Great. And Brian, we did have another question come in from Costa Mesa. If you've got your screen up, I'll let you read that and address that one.
Does HADR pose reorg challenges? Not necessarily, no. It is reorg is logged, so in that, anything that's logged in a database is also replayed on your HADR standby system. As long as you have a good network pipe between your primary and standby, and you don't have a lot of contention or congestion between the two, there's not necessarily any challenges with HADR.
Okay, great. We still have plenty of time to answer some questions, but let's jump into some of the wrap-up details, and maybe just for a little bit of entertainment, let's jump to the movie slide and give people just a quick run through of some of the images that they saw. Just this kind of a little side trip, and let's see what people recognize.
Okay. Like Ray said, you'll probably be able to tell, when I graduated from high school by the movies I have here. But Tommy Boy, Spaceballs, who could forget Fast Times at Ridgemont High if you're around my age? The Goonies, this is the Truffle Shuffle. I don't know if you remember that, but it's on TV now and then. Caddyshack's one of my all-time favorites. Charlie and the Chocolate Factory, Stripes, Austin Powers, Raising Arizona, another one of my favorites. Airplane, Better Off Dead, Good, the Bad, the Ugly, Dumb and Dumber, very popular. I assume most people got that one. Ferris Bueller's Day Off, Naked Gun, excellent movie. Vision Quests, I had to get some trim exercise pictures in there. Star Wars, I thought this was good for the compression part, this scene. Young Frankenstein, Animal House, of course, Christmas Vacation, Rocky III, and one of my other favorites, Something About Mary.
Nice. So
that's it.
Well, that's a fun little side trip. I was going to say, let's go ahead and jump to the resources page, and I know there's probably some things people can go to on their own if they want to dig deeper into this. And don't hold your questions back. We'll take them right up until we hit the last slide here, but we are getting close to wrapping up. If you want to slip one or two more questions in, we'll be glad to take those. But Brian, why don't you take us through these resources, and then I think we've just got one more slide before we close out.
Okay. Yeah, resources are basically the information center for version 9.7. Tons of information out there. You can just search on storage management features and get some of that. The second one is how to shrink your DB2 for LUW using value compression. This is a great article by Jen Seifert from IBM that kind of walks you through that. The query for finding tables that could benefit from value compression is hers. So I wanted to give her props for that. And the last one is the version 10.1 Information Center, where we got some of the new features from. Great.
Well, let's go ahead and jump to that last slide. And I want to wrap up by reminding folks that at XTIVIA, we offer solutions and services covering business intelligence, data warehousing, portal and application development, and data management. If any of those happen to be any needs you have, one of our team members would be glad to visit with you about that. You can also look more into some of the details, some of our clients that we've worked with. We have a bunch of very highly visible clients that you'd recognize. You can visit us at XTIVIA.com or our DBA focused site, Virtual DBA. If there's any specific needs that you have, you can email at info@xtivia.com or call the toll-free number there, and we make an effort to return any inquiries very quickly. I think you'll be pleased with the response you get. I know Brian would be glad to answer any questions. He was willing to put his email address up there, and surely you can shoot any messages to him if you have any specific questions. But we want to thank you for taking the time here. Brian, I want to thank you. I know that you put a lot of time and energy into putting this together. And on behalf of the audience, thank you, not only for those attending today, but we will have this available within 24 hours online. For those of you that attended today, you can access that. We'll give you a direct link to be able to download or to view the video as well as download the slides. And we'll also have a page where people can register to view this in the future. So Brian, thank you. To our audience from across the country, thanks for taking the time to spend with us this morning. And we'll encourage you to keep your eyes out for upcoming webinars on both the XTIVIA and Virtual DBA websites. Thank you.